Hello, 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 hello. Welcome everybody to another episode of what can we call our show? Let me know in the chat if this was a show, what would we call it, or a podcast? If this was a show or a podcast, what would we call it, guys? The first icebreaker, let me know. Let me know in the chat. Come up with creative names. Yo, Najoli, am I audible? Okay. All right. I'm seeing where your minds are going to. Tote is saying ALX and chill. Scott says data daily. All right. All right. Those are awesome names. Those are cool names. Funny enough. Okay, let me think of one myself. Okay. I wanted to say ALX after hours, but I think for most of us, the sun is still out while this session is happening. So yeah, I don't think that will go. But thank you very much for indulging me. It's a very creative name. Very creative names. Okay, ALX fire. Oh, I love these sessions with you guys. You guys are amazing. All right. So today we are continuing. We are trying to build up our knowledge of the basic concepts before everything starts coming in hard. Phrasing. Anyways, today's topic we're talking about big data mechanics, talking about storage, retrieval, and streaming. So from the start, you would see, I mean, from the very first session, I went ahead to talk to you about to give you an overview of why you are here in this particular track. And one of the main reasons you are here is to know how to build pipelines. So you hold that one, keep that in your pocket. But this pipeline is made up of different parts, different components, different concepts. And so before we get to building, we have to understand why we use each tool. We have to understand, okay, when we want to stream, why are we using Kafka? When we want to store data, do we use a lake or a warehouse? Why are we using S3? Why are we using our Snowflake? Are we still together, people? Let me see your emojis if we are still together. So we're building our pipeline, our knowledge pipeline. Are we still together, people? So we don't get somewhere and we start asking, why is this? Why is this? Why is this? No, you are free to ask, actually. Well, I want, as much as we can, I want us to grasp these concepts, hold, so that when some questions arise, even before they arise, our mind already knows where to go to. All right. So, I'm here with Najoli. Najoli, say hi. You can unmute and say hi. Um,
Hey guys, hi.
yeah, and you know me. I'll still introduce myself later. Before I introduce myself, if you've got any questions, please put them in the Q&A in the chat. They might be missed. Use the chat feature liberally. I know some of you are having your lunch now. You can at least type it one hand if you're watching the webinar with your phones. And don't forget to kindly listen, learn, and engage. So when I say, let me see those emojis, let those emojis pop. Naturally, do you see those emojis pop? I don't know, because there's sometimes where I can't see them and they're going off. Do you see the
Yes,
emojis?
yes. I'm seeing them on my side.
Okay. I don't know if it's a Zoom setting. Hi, Tam. Only when I see in the chat, it's only when I see in the chat, you guys type in chat that I can see it, but here I don't see nothing. All right. It's me, your one and only technical mentor for the DE program. I love you guys. It's me, Kayode Balogun. And let's have fun together. Okay, so clear my throat. I noticed one or two things, especially from the last session. So we didn't do anything too serious. You guys are we didn't do anything too serious. We just used a tool to draw a very basic architecture diagram of a simple pipeline. Do you all agree with me? That's what we did. For those of you who can remember the last session. Yeah, speaking of which, naturally George is asking where he can find older webinars. I thought they were already. I'm suspecting he's talking about older DE webinars. I think they are on the eHub. Are they there?
Yes. They are on the eHub, all of them actually from the very beginning. You
All
should just
right,
find them there. Yeah.
all right, George. So there you have it. I hope your question has been answered. So yes, where was I? Where were we? Um, so we just we just did a very simple architecture diagram of which everyone should be familiar with. Um, how do I put this? Nothing too stressful for now. So we're like I'm going to keep hammering this period. I want us to really, really grasp the concepts. And then I hope we are still practicing our Python and SQL. For those of us who have gotten to this aspect, gotten to this part of the material on Athena, you can see why. Even though, yes, you still see that Athena tells you we're just trying to familiarize ourselves with the concepts. You see that you're going to need them later. And before I move on, how many of us have installed Docker? Let me know in the chat. Let me see your emojis. If you've installed Docker, let me see your thumbs up. If you've installed, you can type it in the chat if you've installed your Docker for both Mac and Windows. Natalie, are you seeing emojis?
No, no one has reacted yet.
Ah. Okay.
There's a chat. That's an emoji. I've seen an emoji now.
Okay. Okay. Hmm. Okay. Please and please kindly follow the installation guide on Athena. If you have any issues, take a screenshot. On Athena, the installation is for Windows, but it's simple too for Mac. You just install next, and you have it. And then you can see on your terminal. I'm sure all of us here did Python. So I'm just going to say, you know where to find your terminal, you know where to go to your terminal, and then check the version of Docker you all have so that when we start, we will all be good to go, good to go, good to go. Are we still together, people? Don't worry, today we'll just be having a very nice time with the theoretical concepts and just grasping them. Are we still together? You guys are Pythonistas, so you guys don't have any issues when we start going down the line. I believe so. Before I even continue, how have the MCQs been? How did you find the MCQs? Easy, okay, difficult? Let me know in the chat. Okay, but tricky. John says easy. Brenda says okay. Okay, all right. But I hope as you all are doing the MCQs, you're not just doing them to pass, but to grasp the concepts. So that when you're making decisions, yes, there are a lot of tools that can help you, but so when we are talking, you see now I could easily say, okay, you guys should just go to your terminal and check your version. When we get to later stages, I will just say things. I don't have to start explaining that the terminal is the thing where you can only type and how you can look for no. So once you grab these concepts, when I say one or two things, you guys will already know what to do. Are we still together, people? Yeah, it's supposed to be at least a little bit tricky. All right. So let us begin. So today, we'll take a quick look at the mechanics of the data ecosystem. We'll cover how we can store our data efficiently We can access our data across multiple formats and platforms, look at APIs and JDBCs. And then we'll demystify streaming, we'll break down how real-time data flows and how to harness it. If you listen closely, we should come in handy when you are tackling your MCQs. Alrighty, let's go. Storage, big data mechanics, and here we are starting with storage. I hope we all still remember the concept of the pipeline in our heads. Hope you still remember our pipeline. Where we have to extract data, transform it, load it, or we have to extract data, load it, transform it. Yeah. In all this data has to sit down somewhere. That's why I say we start broadly and then we start looking at each component. So that when we start implementing them, we know what we are doing and we are not lost. I hope we are still together. As you can see here, in all the processes you're going to do, storage is very, very fundamental. Before the tech that could help us with, cloud native storage or, cloud native data lakes, data was stored in files, blocks, or physical servers. In fact, some companies they specialize in helping you migrate your data from physical servers to the cloud. And trust me, if it will cost you something trying to do that, especially if you don't have the internal technical know-how. But the good thing is nowadays, cloud providers they help us with scalable object storage. Even though you don't pay upfront, by the end of the month, you would receive the bill. As many of us who are familiar with AWS can testify. So at least it takes away, some aspect of managing and maintaining the infrastructure, or even liability for one or two things. So yeah, we'll look at different storage types, their structures, the structure and the examples they go for. And then we're going to have, do you call it now a thought, what's it, an exercise, a mental exercise we'll all do in our head based on a real life. We're going to use a real life study case. Let's say we're in charge of it. We're going to be using a social media company, TikTok to be precise, because I have a feeling all of you are on TikTok. If you are not on TikTok, let me see your emoji. Or rather, let Najoli see your emoji. Or you can say it in the chat. I know all of you are on TikTok. And this exercise, when we get some of the fundamental knowledge with storage, we'll see how everything fits in. I hope we're still together, people. So, among our storage types, we have our file, our block, and our object. Nothing too serious, guys. The key difference is just in their structure and what they are best used for. Your file, the structure is the hierarchy in files and folders. If you want to store simple documents, you have an application where documents are involved. Okay, the storage type is going to be a file. And they have examples like your network file system or your server message block. With this explanation of the file, are you all still with me or is anyone lost? Please let me know. Is everybody still with me? I need to be able to see these emojis. Yep, you can hear you. Okay. Yeah, I know you guys can hear me, but is anyone confused? You have an application where documents may involve. Let's say you're building a a journaling app or a to-do list app. Where the data engineer in the company that does that. When you want to store the document, what kind of storage type would you use? Let me know in the chat. Let's start from there. Let me truly know if you guys understand what I'm saying. What kind of storage type would you use? Would you implement? Or a word processing app, if there's in the cloud or something. I have to store for a lot of people. Okay. It is very important, very, very important that we grasp these concepts. Very, very, very important. So you don't get lost when we're writing code, and so we know what we are doing. Okay, good, correct. Next, we talk about the block storage type. Fixed sized in chunks. Good for high performance databases. Use a hard disk drive and a solid state drive. And then we have the object storage type, where you store data and metadata for structured big data on cloud platforms like AWS S3 and Azure Blob. All right. Okay, I see some masters coming in. Cool. Okay. Now they are familiar with some of our storage types. We look at our data lakes and our cloud storage. Yes, I believe it was the last session where we had to understand why when we want to, we briefly just went over the fact, talking about where if you wanted to keep data that could feed into your Power BI or analytics, or you want to run analytics on a piece of data, the kind of data storage you use will be a data warehouse. And earlier, we just briefly touched on wherever I can just get a lot of structured, semi-structured, unstructured data, or in more simpler form, data that is anyhow, any kind, any form. You can just keep them in a data lake. And then from there, maybe you start processing, cleaning it up, etc., etc. Yeah. So you see here that our data lake is typically cloud native for storing all kinds of data, structured, semi-structured, and unstructured, especially data in its raw form. Normally, or unlike a data warehouse, which requires a fixed schema, our data lake does not. And it normally separates compute from storage. Are we still together? With our data lakes, we use schema on read. I mean, schema is only when you want to read data or when you query. Is what I'm saying. Is it making sense? Okay. Some of the examples you see, especially when you're testing APIs, some of the small exercises you see, find out, okay, yeah, you are streaming maybe from a platform, but most of the time you are doing it locally. But once you are using, cloud native architecture, you would see the advantage of separating compute from storage. You see how it's easy for you to scale independently, especially when it comes to, like, call it cost efficiency. Now you're trying to save cost. This is where this comes in very, very handy, and it's very, very important. So now data lake, we have three main storage zones: bronze, silver, and gold. Bronze, or like I said, the first stage is data, the way it came in. Here, this lake even looks clean. I want you to imagine a very, let's say, dirty lake now, where everything coming in is messy, redundant, etc. And then the next stage is silver. This is data that has been cleaned and filtered, or even enriched and transformed. And the last stage is gold, where it is ready for analytics or machine learning. The data that can directly feed into your Power BI or your SageMaker, or maybe even the notebook you're working with. Are we still together, people? Am I making sense? Do we understand? Do you understand what's happening? Let me know in the chat. I can't see the emojis. Can I move on? All right. So now that we're familiar with our data lake, where everything just comes in before any process is done, before anything is, as one of our first story, one of our first ports of call when it comes to storing our data. We'll now look at the process of ingestion, processing, and consumption. Storing that data is just the beginning. You need to get it into the lake, process it, and make it useful. The story of our lives as data engineers, the summary of our platform. So I'm sure even from the example we did last week, some of us are familiar with our injection tools, or tools we use for ingestion. You can see some of the examples here. It was mentioned there, we did it together. In fact, before I go on, how many of us did their own version of the architecture? Who drew theirs with any tool at all? Let me know in the chat. Did anyone, try to just, it might not be that particular example, it could be any other example or something else that comes to mind, where you just tried it out in your head. Did anyone? If you didn't, that's cool. That's cool. Well, at times it's good to practice these things. They are very, 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 very important. Trust me. Even if you are working on something for your own portfolio, it's always proper to have your pipeline architecture that you can show. After you've shown everything, in fact, it's the way, it's in a way how we can even interact with your pipeline and understand a lot about what's going on. Yeah. So enough of that. Next will be processing. Transform our data. We use Spark, DBT, or Glue. Here in this course, we're using Spark. We'll convert our raw data into structured, usable formats. For example, a Parquet file. How many of us are familiar with Parquet files? Okay. Nothing serious. Parquet file is just a way to make the data smaller, to squeeze it, to make it smaller. When you're dealing with big data and you have to be efficient in all you do. So in summary, a Parquet file just helps you reduce the size of your data. And then the processing helps us to carry our data from bronze to silver to gold using various concepts I'm sure we're all familiar with, like joins, aggregations, etc. And then finally, consumption. The aim of all this is not just to build pipelines and then leave the pipeline so that everything is useful. So business intelligence tools like Power BI, Tableau, or Looker Studio can make use of all the information, all the data that we have processed and kept. And we can train our machines very well, have better LLMs, and more improved chat GPTs. Are we still together? So we've spoken about the data lake. The data warehouse is typically where, you know, where your data has been ironed out, straightened out, where you keep that kind of data. More often than not is your data warehouse. The formal definition, you just say it's a centralized repository, optimized for analysis, where data from, you can see definition there. But think of it as where the work has been done on the data, and the data in data warehouse is good to go. So in any way, in any language in your own head, you can just, once a data warehouse is mentioned, because as a place where data has been prepared, transformed, processed, and is kept. So more often than not, you see that features of our centralized of our data warehouse is a centralized repository. More they make use of relational schemas. You find that when you're using intelligence tools, especially when it comes to analysis and reporting, your rows and columns very important. That's why I find out that so this should even tell you, once you're tidying up data to what you call it, once you're preparing data for a warehouse, you know that the final form should be in rows and columns. It should be relational. I don't know how many of you did I think at the very beginning, there was an exercise there with working with data in XML format, sort in XML. I don't know if any of you from XML you had to make sure you could access it as a data frame. There's a little small exercise there in Python. I don't know if any of you did it. Did anybody do it? Nice. All right. So now that I got it to be a data frame, where if you had to store it, where would you store it? Where will you store it? A warehouse or a lake? With all that work you did, where will you store it? If you store it in a warehouse or a lake? Nice, nice, nice. I know in the olden days I'll say you guys are ready for your certificate, but not yet. Not yet. Till we do one or two things. There's a stage you reach. I'll say right now, guys, I can give you guys. It's very good. Those examples are very, very important so that you can understand what we are saying there. And these concepts become very easy to understand, because if you just jump into it using tools, a lot of stuff won't make sense. If you're orchestrating, okay, you're like, okay, what are you even orchestrating? What are the message brokers? What is the message broken? What is yes. But I'm glad some of you are paying attention to these concepts and carrying out the examples there. You guys are awesome. And then these warehouses, they help, to optimize for query performance. So if you want to query, or query something very huge or large, definitely, what you're going to query it not be those small data sets. They have 60,000 rows. No, heavy data. And then for historical storage, they have to store vast amounts of historical data. So if you want to analyze things that happened in the past, you want to gain insight from the past, what marketing campaigns worked and things, you you know where your data warehouse comes in. And then for scalability, it can always grow. And like you keep mentioning, they are very good in they are special. In fact, they are critical. They are the main actors or the star of the show when it comes to online and analytical processing. Are we still together? Before I continue once again, I hope we've installed, before I even continue this session, I hope we've installed our Docker. In one word, in one word, in the chat, you guys should let me know. Why are we using Docker? In one word, for what? Why are we using Docker? Because people are looking at the slides. I wish I could close the slides and you have already looked at the slides. I know everybody, that's what everybody's going to write. That's what everybody's going to write. I've seen all of you, I've caught all of you. But I'll also give you guys credit where it is due, though. You guys are correct. Yes, you're very, very correct. But even before we continue, I want us to, let's say, for example, yeah, I hope we're still together. Let's say we are to design the data storage strategy for TikTok. We all know how big TikTok is. So we're just talking about the storage strategy. TikTok is worldwide. What will be our strategy for it? We know that it makes use of videos. I know that it's not storing data in one place. It makes use of videos and user info, the username, the comments, and then the state, that is the feeds. So know that we're going to be storing video content. So for storage, let's say our video content, what's 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 okay, let me narrow it down. Let me not say what cloud service. What cloud service would we store this our video storage in? What AWS cloud service could we use? Okay, okay. All of you are very correct, but I don't know how I'm begrudging you guys your points. I will stop giving you guys the answers. Yes, our S3 bucket is more than capable. Since we're using our object storage. And we're going to be using, there's going to be user and social graph, for user profiles. So for our user profiles, where we have structured data like our usernames, our emails, our passwords, what what can we use to query? You've done it. What can we use to query these things? We want to get our usernames, email, passwords. What can we use to query them? Okay, okay. Yes, yes, yes. MySQL or even PostgreSQL. Don't worry. I'm not giving you guys the I'm not giving you guys the certificate now. You guys are getting there. You guys are getting there. Then let me ask this one. All of you are on point. Let me ask this one. If anyone that gets this one, I'll say, okay, you are halfway to getting a certificate. To achieve data consistency, yeah, we all remember ACID. Do we remember ACID? Mm-hmm. What does the A stand for? Especially when we're working with our user profiles. Okay. Yeah, yeah. You guys are all correct, even though someone did spelt it in a very different way, but you're all correct. You have the spirit. Um, you are all very, very correct. Halfway there, halfway there. I thought you guys have forgotten by now. So if you noticed, we use different services. I didn't go deeply into some other things like using Redis for our feeds and sessions, or even Cassandra for likes and comments. But the main thing I notice here is that a lot of things, the main thing here that a lot of things are decoupled. So that if one part goes down, like the comments, video streaming is not affected. So I just said, let's so I just said let's have this, let's play around with this. Let's have this, like what I would say a thought experiment. Let's just have this little mental exercise. That we can understand that it's not just building the pipeline, a lot of things have to be considered. You have to use different services, know where each one fits, different tools, know where each one fits, how they the main thing is just make sure that your pipeline is up as much as possible. Or even if one part breaks, the entire system, the entire application is not broken. Are we still together, people? All right. Okay. Another one. Let's say an e-commerce platform wants to provide a customized product recommendation to users. And you have to know their historical and streaming data. What would you use? A data lake or a warehouse? All right. Let's say a company wants to analyze customer browsing patterns and their purchase behavior from its website. And this data is going to improve, you're ingesting large volumes of images, text logs, and videos. Which solution would you use for storing and analyzing this data? Is it a data lake or a warehouse? This is how I'll catch you guys now. Okay. You guys outsmarted me here. Okay. I need to catch you guys. Okay. This same global business now, they want to build executive dashboards so they can visualize their sales and their performance metrics across the world. Should they use the data lake or warehouse to support these dashboards? Okay. All right. Okay. All right. It appears someone was listening. Or a lot of you were listening. Cool. Thank you. That is encouraging. All right. Now we can go on to containerization. How many of us have installed our Docker? If you haven't, please kindly do. I hope you've gotten to this part. I hope we've installed Docker. Have we? Okay. All right. Only one person is saying installed. All right. So where were we? Data persistence. Oh, okay. Please kindly do ASAP. Data persistence with containerization. So I know I said in one word, what do we need our Docker for? And all of us reply correctly, containerization. But you find out that a lot of things could happen to your database state when the container is stopped or restarted. Are we still together? If we're not together, I can go back to the very beginning. We have the pipeline. This pipeline has components. So many tools that make our pipeline successful. It starts from the ingestion till the end, where we load our data and feed. It delivers value to dashboards, etc. Now we started from storing our data. As it's ingested, it has to go somewhere. More often than not, it doesn't come clean. There are standards: gold, bronze, silver. There's a journey it has to take to get there. There's so many things you have to do. In the real world, in production environment, it's not that straightforward. You have to put in so many measures to make sure that your pipeline does not break. And even if it breaks, your entire system or the app itself does not break completely. That's why it's just talking about sharding, partitioning, storing data redundantly, taking snapshots. So when you are dealing with data in the container, I have to make sure that it continues, it endures, no matter what happens. You have to be able to maintain the application state across restarts. For whatever reason, there could be restarts. And our databases depend on persisted data to function correctly, especially after restarts. There could even be issues where there's an update failure or something, and then persistent storage has to ensure that the data integrity is still up to standard. And when you are scaling, among other things, your data must still be, it must be correct. Are we still together? I just paraphrased a lot of things, and I hope this explanation is simple enough. Don't mind the word containerization. I was speak English. But I hope I'm making sense. Are we still together? And so to help us with our persistence is one tool, just a tool among others, our Docker. The Docker was asking if we had installed. I kind of feel like I know, like I'm feeling like the entire everyone here on this session is quiet where they are now. And I hope that your silence is a sign of you understanding and you staying with me. I hope we still understand where we are up to now. Are we still together? No way, I can feel the silence from here. Are we still together? Okay. Okay. So the thing is, don't worry, guys. We're just grasping the concepts. I think when you start using the tools, they'll stick more. So it's just a tool. You guys have used so many tools from the start of DA till now. For those of us who went through that route. So here we are, just another tool to help us with persistence. That's all. Beyond the individual life cycle of the different containers. So that our Docker volumes easy to use, hope persistence if you want to share data. And um, one advantage they have is portability over, especially when it comes to bind mounts that have direct access to the host files. They are portable, they provide security, backup, and restore. While bind mounts that grant direct access to host files provide greater control and flexibility. Especially when you want to do real-time data synchronizations. That's just the summary of everything that is here. All right. I have a feeling we're still together. So another thing we'll have to be familiar with is retrieval. We've talked about our storage. Yes, you've stored it. Now is to retrieve that data you've stored. To retrieve it so you can move to other places, can flow through the pipeline. So we'll look at different protocols and legacy systems we can use in this process. So our known or our usual suspects or our known cloud providers have different protocols for their different services. You see here, AWS, the transfer family support SFTP, FTP out of the box. Always make sure that your transfer is secure. So it will make sense. Remember from the start, we spoke about plenty things, including securing your data, governance, and etc. to protect it. Even from the fiscal sense, people who don't have access to it. People who are transferring it, there's some people who are up to no good or are thinking of ways to intercept the data. You have to make sure that when you're transferring the data, you transfer it securely. I also together people. And then we see cloud services like Azure that offer server-based block-based server message block-based sharing file for lift and shift scenarios, while manage NFS solutions, that is our network file system solutions that exist in both Azure and Google's GCP are used for Linux-based applications. All this just help us to modernize our infrastructure without abandoning the old ways. So these are examples of the different protocols, our FTP, the old way, supports authentication but lacks encryption. So if you know you're transferring something very sensitive, you can see the issues arising. You can see the ports there. These ports come in handy when you're configuring your cloud infrastructure. But don't worry, even if you forget, it's not something you need to cram. Something that is always accessible. You can just get the port, and so you don't need to cram all this, just to understand the different protocols. Are we still together? Am I making sense? Or I can start. I can bring it from the beginning to here. I'll start. Pipeline. Pipeline made of components. The components, we've talked about storage. Now that it's stored, the data has to move about in the pipeline just the way water flows. But the movement, it can't just move anyhow. There are protocols to ensure our security. Different platforms, especially cloud platforms, have different protocols. We're looking at different protocols and their ports. You don't have to cram them because they're always accessible. We just need to know them. So when we are configuring infrastructure, we configure the right thing. We use the right port. Are we still together? Let me know in the chat. You can even throw emojis if you have followed me from the start till now. So we described the FTP, file transfer protocol. We are now seeing SFTP and FTPS. These two, don't stress yourself, it's just to make sure that it's done more securely. We're just adding security to our stuff. Make sure our data is transferred more securely. So don't mind any big English here. Are we still together, people? Because we need to understand it so that when we're configuring, we are seeing some numbers and we are not wondering where those numbers came from. All right. So this is a continuation of the different protocols, the different transfer protocols. Same explanation I gave. Then there's a thing about, remember I mentioned the old ways. Very important to, integrate legacy systems with the current ones. So to do that, there are adapters and middlewares and ETL pipelines and API gateways that help with that. And one API gateway we'll be looking at will be the REST API. It's always important to ensure backward compatibility while enabling new ones. Remember, you are building on what others have done. More often than not, maybe you're a senior data engineer before you are the main architect of in a large company of a pipeline from start to finish. More often than not, you are going to meet a pipeline. Or more often than not, you are going to meet a pipeline. More often than not, just once you are starting, just say go and unless maybe you're working with you're doing your own little project or on in a rare instance. So you see why it's important for us to have backward compatibility. Are we still together, people? As we are retrieving data, we want to be familiar with REST. This REST we are talking of, it's not the one you do that you can lie down. You Netflix and chill like, what is his name said at the start of this program. No, at the start of this webinar. No, not that kind of REST. This REST is a way for our applications, our software to communicate. And the rest is just representational state transfer, abbreviated. That's what the rest is for. See how mouthful it is to pronounce representational state transfer. Imagine how to say representational state transfer plenty times. No. So it's just shortened to REST. Our REST APIs, all these English is saying not our REST APIs help software communicate between each other. So let's say you wanted to, okay, let's say you wanted to, you're working on a small project and you wanted to stream the current price of crypto, maybe on a simple website, maybe just Bitcoin and Ethereum. So you find out that there are other crypto websites that have APIs that show the current price. So you want your website to be able to extract that information and display. So some sites like that to allow you to have access to the documentation or for developers. If you want the API, here you go. Are we still together, people? So this REST architecture, it provides access to resources through our REST server, where a REST client can then access and modify the resources. Each resource is uniquely identified. And this it can be represented through text, JSON, XML. But more often than not, you find out that most of the time is JSON that is being used. So that's just the summary. Our REST API helps our software applications communicate. There's nothing else. Don't worry about it. They just help our software applications communicate. Like subconsciously, I can feel when everyone is quiet wherever they are. Well, it's all cool, guys. It's good we all know this. Because for example, let me know how many of us did the exercise where we get weather data on Athena. You could do it on a notebook or an IDE. In fact, most of it was already done. You just had to change one or two things. How many of us did it? Let me know in the chat. Did anyone do that exercise? You just click on it. I think it's the APY underscore exercise dot py file. Almost everything is done, but it's just something to wet your beak and to test the waters. Najoli, was there any emoji on your end?
Yes, there were some reactions, some thumbs up.
Okay.
It's the chat that
Okay.
is dry.
Okay, guys, don't worry, it's cool. Right now, we are just trying to grasp the concepts before we jump into the deep end. Yeah. So relax. I feel like I should just even skip this slide. You think of your REST REST API just for software applications to communicate. That's all. So anything you're doing, you should just have that as the what you call it as your blueprint. Yes, if you go deeper, you see things like the constraints, the architecture. Yeah, but that's just the main thing. That is the main thing, guys. And we have to know this because even if it's in batch, even if you're working with IoT devices, more often than not, your data is coming from the web. That is why you have to be familiar with this. Stay with me, people. Yeah. So these are just some constraints for your REST architectural API for a REST API. It has its client server, the front end is responsible for the user interface, and the server is responsible for the back end and the storage of data. It is stateless. I mean, no data from the client can be stored on the server side. All session data must be stored on the client side. And then clients should be able to, even though temporarily, cache server responses to improve performance. Sounds a little abstract. That's why I said we can even skip this slide, but just remember, APIs, REST APIs, how applications communicate. So, like for those of you who gave a thumbs up, you found out, okay, they'll say, go there, get your API key. Yeah, there's a client, there's a server. For, I wanted to skip this slide, but let me do something. For those of us, okay, for those of us who did the exercise retrieving weather data, Yeah. Who was the client? You can let me know in the chat. Who was the client? Who was who was the server? Or rather, what was the server? Based on what you did. So you might have used ID, some of you might have used a notebook, but your weather data was displayed somehow. Yes. So I hope little by little we are beginning to understand what we are doing, why we are doing, why we have to know these things. It doesn't sound too abstract. So let me summarize this. At times, there are times where you try to go online and you see, I know there's one guy that I'm familiar with 404, 404, 403. Which one is the web page is not found? Is it 404, 403? You guys should remind me. Thank you. So while using REST, anytime you have a 200, it means your get, post, or delete worked. Your get is to provide readily access to a specific resource, like a weather data. Your post is to create a new resource. You have access to the back end. You can modify info at the back end. You post something there to change something. And then your delete, you have access to delete a resource, to delete a resource. Your put is you can use it to put a new resource or to update an existing resource. This makes a lot of sense when you're writing code and then you have to use get, post, or delete. More often than not, if you find that you're using get, you're trying to retrieve data to display. And if you're testing if something is broken, you see different error messages. More often than not, if it's okay, maybe you're debugging, you see 200, you know that everything worked and the problem is coming from somewhere else. Are we still together? Am I making sense, beautiful people? All right. I'm glad I am. So it's just a simple diagram. You, the user here, some of you that use your notebook or IDs, you sent a request with the code already there on the Python code already there to AccuWeather now. And then the database got the information, got the response, and sent it back to you. This is what happened, this diagram of what happened in that exercise. You're able to get an output, you're able to see the weather because okay, 200, everything was okay. Maybe there was a syntax error in your code or something, you won't get that 200, you get maybe another error telling you, okay, this is what is happening there, or the message was not even received, or the request was not even received. If they had a downtime, if their server was down, you'd have gotten a different error message. So even though technically you didn't have to store anything or build a pipeline for anything, but you understand now how you retrieved your data with your API, but they had to go to the entire ELT process to have that weather data available for you. They got it from satellites, they got it from so many other sources. Now you just went there with your API key and were able to get the weather data. So if you had maybe if you built an app or just a simple website to display the weather for your current location, your API will be feeding it there. You find out that you could set the time. Do you want it to be 2 hours a day, 3 hours a day? So it's not every time you go there, you build your app and automatically how you want the data to be displayed is displayed. It's just the client, that's you or the front end facing app you've written, communicating with the back end. I hope we are still together. So, like I mentioned, when I said AccuWeather got their sources, got their data from different sources, you find out that when it comes to retrieval, more of the not you'll be dealing with IoT devices, and here we'll be looking at ingestion architectures. So, there's a particular time in my life when you mentioned an IoT device, the last thing that came to my mind would be a laptop. I always thought of them as microchips or things in sensors like smoke detectors and like, but you find out that a lot of the things we use every day are IoT devices, even our traditional PCs, our laptops, our mobile phones, heart monitoring implants. So these IoT devices that have softwares, they have software sensors and the technologies embedded in them take many shapes and form and perform different functions. More often than not, they're connected to the internet. That's how they can easily communicate to send and receive data. And trust me, the amount of data they are generating is growing. And the aim is to ensure that interconnection and exchange over the internet are simple and efficient. Are we still together? So yeah, we mentioned how the amount of data they generate grows in volume. We found out that this data can be sent through low latency environments too, meaning that millions of devices have to correctly connect and data ingested rapidly. I think this is just hitting to the point of we're dealing with big data now, guys. That's why we're using specialized tools. That's why we have to understand the components of our pipeline. That's why we're trying to grasp this concept, understanding why this is here in the first place. What does it do? So you see here, we talk about injection architecture, and that's what we did in the last session, knowing the tools we can use to start drawing our architecture diagram, because you'll be expected to present it to defend what you've built. Yes, you build the pipeline, defend it with your architectural design. I will see together, people. So we spoke about APIs. Another way to retrieve data to be a JDBC connection. That is simply a Java database connectivity. Is apart from REST API, have a Java API that helps us interact with relational databases. I don't know, for some of us who have installed what you call it, Java. You see, Java powers how many billion devices around the world? I don't know if any of you have come across that thing when you go to Oracle, is it Oracle's homepage? So you find out that you have to get data from some of these devices. You have to do that by establishing a JDBC connection. Um, if we look at the sample here, connection con equals to driver manager.get connection. It looks very familiar to something we've done before, especially those of us who connected my SQL workbench to my Jupyter notebook. I don't know if any of us can remember doing that. Do you remember connecting my SQL workbench to my Jupyter notebook? Because sometimes when I reference some things on the DA course, I feel like not everyone connects. Now, Julie, are there emojis going out?
I'm not seeing any right now.
Okay, but I'm seeing in the chat, yes.
Yes,
So
okay.
this code snippet, does it look familiar? I know, I have a feeling some of you here were with me when I did the 5 hour, close to 5 hour office hour, trying to handle these issues, connecting my SQL Workbench to my Jupyter notebook. Yes. Okay. All right. Awesome. So don't panic. If you notice, for now, we haven't touched the episode. I just say, let me bring this code snippet so that all my warnings to practice your SQL and your Python doesn't go into one and comes out of the other. So you can see here how, for example, MySQL uses the MySQL connector that we've used and the the J driver to establish a connection with devices that were written in Java. So here you find out that there's a lot of similarity in the syntax of, you use syntax similar in SQL and Java just to establish the connection. And like I always say, don't worry about the syntax. But this is just a code snippet. So you use JDBC where I'll try to work with Java APIs. In fact, don't worry about the code snippet. I just have to remind us. I'm not supposed to show you code snippet. Now I just have to remind us of what we did. Let us that. Don't panic. Even though you see some Java syntax, it's just don't panic. I know we didn't we didn't do Java, we did Python, but you practice your Python, just switch up one or two things in Java, but don't worry about this. But it's just good to have a broad, just general knowledge about this. You could go deeper. Yeah. So this JDBC just helps us with connectivity when it comes to our Java API. That's all. That's the summary. Are we still together? So again, JDBC, most important thing is closing. Don't forget to close. When you finish using your resources, don't forget to close the resources. There's a line of code and syntax for that, but we won't focus on that for now. But just have general idea. I want to see JDBC or there's a Java API. You know, it's a JDBC connection to retrieve your data, and you're good to go. So just hold on to that concept for now. That's all we need to know about that for now. Now we jump to our streaming segment. Data is coming in live, hot. I think I asked this question, I don't know if I answered last time. Difference between batch and streaming is coming in live, hot. How do you work with it? So you can see here, there's a lot of big English about the processing paradigm that processes data continuously and incrementally as it flows in, and showing the difference between batch that handles structured. No, once streaming, all of you here stream. I know all of you here have Netflix accounts. Streaming data coming like a flood continuously and incrementally. It is real time, happening live. Is often triggered by data events or user interactions. It definitely has to be scalable and responsive. Are we still together, people? Next, we see why streaming matters. Remember when we spoke of IoT devices, social media, financial systems? In fact, there are too many things that are generating data we can't even start mentioning here. And this data that is coming in live, we have to do something with it. It's coming in live, it's coming in hot, it's coming in big. You have to do something with it. You have to react quickly, you have to follow it. If not, it's a broken pipeline already. So you see that streaming helps to power real-time dashboards and alerts improve customer experiences. Imagine I post a video on TikTok, on Instagram, and Instagram tells you, don't worry, by next week, Wednesday, you are going to get it, along with millions of people who posted today. How would you feel? You won't like the experience because you're trying to impress or pepper them, as they say. You're trying to impress your friends or that girl or that boy with your vacation pictures. And then he's telling you, don't worry, it will arrive in batch in next 3 weeks. So you see how streaming helps to improve our customer experiences with live data. It also helps with enabling smarter automation and decision making. And generally, there are three streaming architectures. Lambda, that is a hybrid of both batch and streaming. I'm sure we're familiar with batch. And then cap architecture that simplifies Lambda by only using only stream processing. And then we have microservices-based architecture, where the pipeline is broken into smaller services. A different service for ingestion, transformation, and storage. All these, just make sure that modularity, there's scalability, we can handle the speed coming in. The streaming is streaming. That's just the summary of Big English. So please, let's not forget this concept so that when we start applying them, we know why we are doing what we are doing. I'm glad when I say, okay, I was asking those examples. Why are we using where do we use a data lake? Where do we use a warehouse? So please hold on to these concepts. You are going to need them throughout your journey. And as I've seen earlier, we keep it here, trying the diagrams on the start. When we come to components of our streaming, when it comes to data ingestion, we use tools like Kafka to capture events and data in real time. And then to analyze or transform the data, we use Apache Flink or Spark Streaming. And then to store, I'm sure by now all of us know S3. And here we see an example of us trying to detect fraud from an e-commerce platform, where we use Kafka to ingest data, Flink to process, Redis to hold in memory state for comparisons to see, okay, what's abnormal here? And then Power BI to visualize all the flagged transactions to dashboards. So this is just an introduction to streaming. Let's give us a broad overview. This concept will still be repeated as we go on, and even as we practically start to use all these tools. Are we still together, people? So remember when I said streaming, lots of data like water flowing in constantly, real time. The key tool we use to handle this for this module is Kafka. And why? Because Kafka handles big data, it handles scaling. The volume is going bigger and bigger. Kafka handles it properly. Are we still together? I have a feeling we are still together. So when we're talking about streaming, you hear things like message brokers. Don't worry. They just enable decoupling. And okay, they just help us to facilitate communication between applications. Kind of like our API, but here is just taking messages to and fro from the sender to the receiver. So there's a decoupling between data producers, those who are consuming it, those who are consuming the data, to help with scalability and fault tolerance. like I mentioned somewhere, so that if one component of the pipeline breaks, because at times, even though you do everything correctly, something happened, the pipeline breaks, everything doesn't go down, the application is not destroyed, everything is not a total, it's not a train smash. It can still be going on. The system can still be a lot of other aspects of category, a lot of other aspects in the application can still be up while you are working on fixing a decoupled part that is down. So that's what our message broker does when we are streaming. That's all. Nothing too complicated. So when you see a message broker, you see the diagram that no. That's just all the big Englishes. This is just what it does. I will say together. All right. So, like I mentioned earlier, Kafka, very critical when it comes to streaming. The tool we'll be using, especially to build our real-time data pipelines and streaming applications. It has a lot of advantages, high throughput, fault tolerant messaging. So when it comes to Kafka, these are key concepts we should be aware of. The producer who publishes data to Kafka to just, in fact, I always have, think of the producer as the one who creates data, and then the consumer who consumes incoming data, and then the broker. This is the Kafka server that stores the data and serves whoever wants a request. What do you want to take? What do you want to take? The topic, the channel where the producers write and from where the consumers read. The partition, the division that allows order to other things. The offset, the unique identifier of a message in a partition. The message needs to be identified to know who it belongs to, where is it coming from, where is it going to. Are we still together? So when it comes to design decisions, things like the append-only logs and leader follower replication, customer managed state might look abstract for now, but as we go deeper, I understand how the append-only logs help with order. Things are not scattered. Consumer managed states helps things be flexible. And leader follow application just helps to make sure that our pipeline is running, is available, has the highest availability and also durability. But don't stress about that for now. I hope we've picked up one or two things because we are picking up speed now. But it's good we are familiar with this. So, like I said, today, it's not like when some of us first joined, when I'll say, go to the terminal and I'll start describing where the terminal is. No, become familiar with this concept. So as we go further, once I mention it, no more explaining again. We know why, we know what, we know where. Are we still together, people? I hope we've picked up one or two things today. And now before I round up, I I I think the last session someone was requesting for books. I gave The Signal and the Noise by Nate Silver. And it's just another one I feel where as data engineers should go through. It's titled Everybody Lies, Big Data, New Data, and what the internet can tell us about who we really are. If you can, pick it up, go through it. Remember, there is life beyond the pipeline. And more often than not, beyond building pipelines, all the other things we acquire around influence how you even go about building your pipeline. Yeah, I hope you picked up one or two things today. I'm going to the Q&A now to see if there's anything there. Now, Jolie, if you can you please fire away on the chat? Okay, George is asking. Then I put my, hey guys. Okay, George. Okay, thank you for this issue. I think we're aware of it. Kindly take a screenshot and put it on answer base, please. If you can hear me, please reply in the chat. This issue where you missed the deadline and it's getting zero, kindly take a screenshot and put it on answer base, please. Yeah. I think you're the second person we are seeing with this issue. You're supposed to have supplementary tests. So, okay, Animal says, do cloud vendors provide us also authorities? Yes, they do. Let me to the data warehouse when and give examples. Yes, they can. It depends on what you want to do. So, like, I think this ties into the third question. Let me show you a proof data from beginning to end. From the very first day of this course, we've been describing a full pipeline from beginning to end. We're not jumping into the tools directly because even yesterday, the last webinar session I had where I showed you guys how to design the architecture using draw.io. A lot of people struggled with it. So we have to get the basics first. You will be building full data pipelines from beginning to end. Is that okay, Anonymous? You will be building them after we've shown you how to. But for now, we need to grasp the concept so that we're not sounding abstract. All right. So I'm not seeing any other question. Okay, thanks, Najeli, for the poll. Yeah, I think I can go to announcements now. So yeah, please don't forget your community if you have any issues for support. And also on Fresh Desk and Answer Base. For those of us who have had that issue with missing the deadline, can you take a screenshot of what you're seeing and put it on Answer Base? Don't forget your next assessment. The submission is Tuesday next week. Sorry, showing Monday here. And it's big data storage. But you're not alone in the community. Your alumni volunteer mentors are there to support you. Don't forget to post your wins and new insights on your squad faces to engage your squad mates. I wonder how many of you did that. Okay, nobody even signified they did that diagram, but it's cool. It's cool, guys. Don't worry. See you next week. Please don't forget to
There's one more
practice.
thing,
Okay, what's that,
Coyote.
man? Yeah.
Oh, the data engineering in the real world session is happening this Friday, 5 p.m. ET. The link will be shared. It's probably already in the communication space on your eHub. So see you then.
All right. All right. Thank you very much, Michael. Cheers, everyone.